Okay, subtraction of two vectors simply means the addition of one vector with a negative vector. What does it mean by negative vector? Okay, negative vector v, for example. What does it mean by this? It means it goes opposite direction of the other. Okay, if v is -1, 2, 3, minus v is 1, -2, -3. Okay, so it just the subtraction of two vectors. It just simply means the addition of the two vectors with a different direction. Okay. For example here, if you have vector u with this component and vector v with this component, then u plus minus plus with negative vector v is u1 plus with negative v1, u2 minus plus with negative v2, u3 plus with negative v3. Okay, or you can just simply write it this way. Okay. Okay, now I will show you how to draw the resulting vector for the subsection of two vectors. Okay, so let's say if you have vector u here to be in this direction, okay, and you have vector v in this direction. Okay, this is vector v, right? And you were asked to find the subtraction of vector u minus with vector v, and we know this subtraction equal to vector u plus with the negative of vector v. We know already what is vector u, which is that. What is the vector negative v here? Vector negative v here is the opposite direction of this vector. Okay, so the length should remain, only the directions change to that. Okay, so this is negative vector v. Alright, so you have two choices here, whether you want to use the first law, the triangle law, or the second law, which is the parallelogram law, to find the resulting vector. Okay, so I show you the first method, the first law, okay, which is the triangle law. Right, now we will connect vector u with the negative vector v. Okay, so draw vector u. Vector u is this is u. Okay, this is the initial, and this is the terminal. Okay, by using the triangle law, we will connect the terminal point of the first vector with the inertial point. Okay, where is the inertial point of the second vector? This one. Okay, so this should connect to that. Okay, with where is the direction? The direction is to the left. So it means here it go there. Okay, so remain the direction here. This is your negative vector v. Okay, so this is the terminal. This is the inertial, and the resulting vector for if you use the triangle law is the inertial must connect to the terminal. So where is the direction? The direction is that way. Okay, so This is the resulting vector for u minus v. Understand? If we use the second law, parallelogram law, okay, we will always start with the first vector, which is this. Okay, there is your u. Okay, for parallelo, it always connect the initial point of the first vector with the initial point of the second vector. So initial connect with the initial. This is the initial, and the initial of the second vector also start here. Okay, to there. That is the direction. Okay, this is negative v vector. Okay, so the parallelogram will form whenever you connect these two. This will remain that way. Okay, you follow there because this is negative v and u is there. Okay, this is vector u. Okay, the direction is there, and the resulting vector of the u minus v is this. Okay, so that is the resulting vector. Okay, u minus v. Right? Understood? Okay. Now let's proceed to look at the sum of all vector. Okay, so the sum of vectors. Okay, for example, number 1 here. Okay, the summation of A and B here. Okay, you have two vectors. Okay, the summation of these two vectors will result to a single vector, which is C. Okay, where C is a vector joining the inertial of the first vector to the terminal of the second vector. So this is the first vector, this is the second vector. So C is the resulting vector from the summation of A and B, where C is formed by joining the inertial of A to the terminal of the vector B. Okay, let us look at here. Okay, so this is your C. C is formed, okay, is the resulting vector from the summation of vector A and vector B here. Okay, so C is produced by joining the initial of the first vector, because A is your first vector, so this is the initial of your first vector joining to the terminal. So this is the terminal of the second vector, which is your B. So join this. Okay, make a straight line. So this is your single vector C, which is the resulting vector of summation vector A and B. Understand? Okay. We are not only allowed to sum two vectors, but we can have more summation of vectors. Okay, for example, number 2 here, where E is the single vector, okay, produced from the summation of vector A, vector B, and vector D. Okay, so let us look at single vector E. Okay, so note that this is the single vector E. Alright, so E is the resulting vector from the summation of vector A here plus a vector B here plus vector D here. And why did I say this is the resulting vector? Because it connects the inertia of the first vector to the terminal of the last vector. So this is the single vector, which is the resulting vector from the summation of A, B, D. So the rule here is, okay, how to find or to tell which one is the resulting vector and which is the summation vectors. Okay, you just look at this. All right. So if you choose to apply the first law, which is the triangle law, okay, the resulting vector is always the vector, is the single vector where it connect the inertia. Sorry, wait. Okay, it connect the inertia of first vector to the terminal of the last vector. So if you have two vectors, for example like C here, it will connect the inertia of the first vector, okay, to the terminal of the second vector here. So connect the inertia of the first, okay, which is A, to the terminal, okay, this is the terminal of B, the second vector. So the resultant vector is C. Okay, it always be like that. It doesn't matter how much vectors you sum. Okay, the resulting vector, the single vector here, okay, the single vector is always the one that connect or join the initial of the first to the terminal of the last. Okay, so since you have three vectors here, okay, so the first is the vector A, and the last is the third one here, which is your D. Okay, so it follow A plus B plus C, and you mark this is the terminal of your last vector, and this is the initial, okay, initial, and this is the terminal of the last vector. So when you connect initial with the terminal, okay, this will produce the resulting vector, which is the single vector produced from the summation of the three vectors here. Okay, so the arrow is there. Okay, so there are two resulting vector here, which is C and E. Okay, while the rest here, A, B, D are vectors, okay, that you sum to produce C and E. Do you understand? Okay, and the second one, if you choose to apply the parallelogram law, okay, make sure it always form the parallel form. Okay, so parallelogram is like this. Okay, where in parallelogram we always connect the summation of vector is always by joining the initial with the initial, and the resulting vector, which is the single vector produced from the summation of the vectors, okay, two vectors, parallelo only can be applied to two vectors, okay, is the diagonal of the two vectors. Okay, so the summation or the single vector is always here, okay, in between the two vector that we sum. All right, so that's it. Okay, next is scalar multiplications of vectors. Okay, let's say if we have k, where k is a scalar. Scalar mean it only has the magnitude. Okay, so can be it is a number. Okay, a real number, and u represent a vector. So here you have u, where u is a vector. When you multiply k to u, okay, here is what you is the property of the scalar multiplication. Okay, multiply k to vector u means you have your vector, okay, has length k, okay, time to the length u. Alright, so if your magnitude of u is 3, okay, and k here is 2, it means here that your new vector is 2 times the length of vector u. Okay, so if u is just this length, okay, your 2u will be 2 times the length of the current vector. Okay, and if the vector if the scalar k is greater than 0, okay, means it goes to the positive side, greater than 0, then the direction of the new vector you multiply with scalar k will be same direction as your current vector. Alright, but if you choose k to be less than 0, means negative side, because 0 is here, okay, greater than 0 will be always positive, because 0, 1, 2, 3 until infinity, so positive. And if it is less than 0, mean it will go to negative 1, negative 2 until negative infinity, so this is negative side. Okay, if this happen, then your new vector will be the opposite direction of your u. Okay, do you understand? If this is your vector u and k is 2, then your new vector will have the same direction as your current vector. Okay, but if I put negative 2, k is equal to negative 2, and this is your u. Okay, negative 2 means it will have 2 times the length of the current vector. Okay, 2 times of the current vector, and the direction will be the opposite of u. Okay, if the direction of u is to the left, to the right, now negative 2 will change the direction of the current vector to the left. Okay, so this is negative 2u. Clear? Okay. Okay, now let us look at the summation and the subtraction as well as the multiplication of vectors. Okay, let's say if you have vector u to be here, to be in this component. Okay, so this is the component form of vector u, and you have the component for vector v here. Alright, okay, so for a, you have to multiply scalar 2 to your u vector u, okay, and you have to multiply scalar 3 to your vector v. So what you do is, okay, this is equal to 2 times negative 1, 3, 1 plus with the multiplication of 3 times 4, 7, 0. Okay, so be careful with your writing. Okay, the component is separated by using the comma. Okay, so make sure you write it in a proper way, okay, in a correct way, because if not, you'll be confused, okay, or you will
just treat this as plus or minus, something like that. Alright, so this is equivalent to, okay, you will have new component form where it is double the first component. Okay, to 2 times -1, you will have -2. Each of these you multiply with 2, okay, each component. So 3 times 2 will be 6, 2 times 1 will be 2. Okay, plus, okay, you solve the bracket first to get new component for vector v, which is triple the current component. So 3 times 4 is 12. 12. 3 times 7 is 21. 3 times 0 is 0. Okay, now you proceed to sum this. Remember, for summation or subtraction, you must add or subtract the first with the first component, the second with the second component, the third with the third component. Okay, so the first component is -2 plus 12, that is 10, comma. Okay, since 6 plus with 21 is 27. That is your second component. And lastly is 2 plus 0, that is 2. Okay, now that is your third component. Alright, so 2u plus 3v is equal to 10, 27, and 2. Okay, so you add or you subtract a vector, you should get the vector. Okay, so if you do and you get a scalar, there is a sign that there must be a mistake anywhere, okay, somewhere. Okay, so we're done with A. Now B. You need to deal with u minus with the triple v. So we have done for triple v here. Okay, and u is here, so u minus 3v is equivalent to -1, 3, 1. Okay, so minus with the triple v is here, 12, 21, 0. Okay, so the answer is -1 minus with 12, that give you -13. 3 minus with 21, that will give you -18. 1 minus with 0, that will remain 1. Okay, so this is the answer for B. Okay, so for C, okay, the two straight line here means the magnitude. You need to find the magnitude or length. Okay, so length, remember, it is equivalent to the square root of the first component, which is x1 square plus x2 square plus x3 square, if you have 3 components. Okay, so what you do here is you need half of the vector u. Okay, so solve for half u first. Okay, what is half of vector u? Half of the vector u means you multiply scalar half to your u. Okay, which is equal to minus half 3/2, 1/2. Okay, now you need to find the length of this. So summation, the magnitude of half u is equivalent to minus half square plus 3/2 square. Excuse me, my pen. Okay, square plus half square. So that is square root of 1/4 plus 9/4 plus 1/4. That is 11/4. Square root of 11/4 is equivalent to square root of 11/2. Okay, so we're done with this. Hopefully you understand on how to sum and to subtract and to multiply a scalar to your vectors. Okay, now let's move on to parallel vectors. Okay, what is parallel vectors? Parallel vectors, when you have two vectors and they have same direction, okay, whether their magnitude are same or not, okay, they are said to be parallel. Okay, so we do not consider the vector based on the magnitude, we just look at their direction. If their direction are equal or in the same direction, then we can declare that the two vectors are parallel. Okay, so do you understand this? Okay, for example, if you have vector u to be in that direction and vector u, and you have vector v which is this long but still in the right direction similar to u. Okay, so you can declare that these two vectors are parallel. Okay, so we didn't care about the magnitude. How long are they? We don't care. Okay, as long as they have same direction. Okay, if you have vector u to be in that direction, okay, and vector v, okay, to be in this direction, this is not parallel. Okay, they are not parallel because u goes to the right direction while v goes to the left direction. So they are not parallel based on the definition of parallel vectors, where they should have same direction. Just care about the direction. Okay. Okay, now let us look at the properties of vector operations. Let's say you have three vectors. You have vector u, vector v, vector w, and let a and b be a scalar. Okay, so the first one, you add vector u with vector v. Okay, if you don't want to do this, you can reverse, or you can swap the position of your vector by summing the vector v with vector u. Okay, so this is fine, you can do this. Okay, so if you add three vectors, okay, vector u plus vector v plus with w, you can choose whether you want to sum the u and v first and then later sum to w, or you can choose to sum v and w first and then add it to vector v, also can. Or you can change, or you can swap the position of u and v first and choose which one you want to add first. It is also okay. Okay, so there is no effect on this. Alright, so you can do this. Alright, so vector u plus with 0, okay, 0 vector, 0, 0, 0, you get the vector u back. Okay, and then if you have vector u plus with negative vector u, this is equivalent to u minus u, so you get 0. Okay, so any vector, it doesn't matter, even if you multiply with 0, you will end up with 0 vector. Okay, so you get 0. Okay, so if you multiply your u, okay, vector u to 1, that is equivalent to the vector itself. Okay, if you multiply scalar a and b to vector u, that is equivalent to, you solve for multiplication of a and b first, so you multiply the scalar first and then you proceed with multiplication with vector u. It's fine. Okay, you can do this. Alright, next is if you need to multiply a scalar A to the summation of vector U and vector V, okay, you can expand the bracket by multiplying A, okay, scalar A to vector U plus with the multiplication of A to vector V. Okay, so you expand this. Or you can solve U plus V first, okay, and do the multiplication later. That is also fine. Okay, same goes to A plus B times U. Okay, so you can solve for A plus B, the summation of A and B first, and then you multiply with U. Okay, here is addition of scalar. Okay, multiply with vector U. Or if you don't want, you can expand the bracket by multiplying A with U plus with multiplication of B to U. Okay, so you have two choices here. Which one you want to use is okay. Okay. Okay, so the last part of this lecture is a unit vector. Okay, unit vector is denoted by that symbol. Okay, we write our vector u as u with underscore beneath it, right? So if you see u with underscore beneath it, this is a vector u. Alright, but if you see a cap, okay, a hat on top of vector u like this is called unit vector. Okay, and unit vector is defined by the vector u divided with the length of vector u, the magnitude of vector u. Okay, so this is unit vector. And the other important property is unit vector must have length equal to 1. So the magnitude of this vector must equal to 1. Then you can call this as a unit vector. Alright, so how to find the unit vector? Just take the vector over with the magnitude of the vector itself. Okay, then you get the unit vector. Okay, and unit vector must have length or the magnitude equal to 1. Okay, so I guess that's it for the first lecture, and we will proceed with a second lecture on vectors in the next day. Thank you very much.